So we want to find the area between the curve f of x and the curve g of x between the x values x equal -1 and x equal 3. First thing I want to do is I want to graph this. So f of x is a parabola shifted up 4 units, and then x minus 2 is a line that's shifted down 2 units. So I want to graph this. So I'm going to do a little sticky note so I can get my grid going. Okay. So let's see here. Maybe something like this will work. All right, so let's graph f of x first. I'm going to do it in blue since I highlighted in blue here. So that's a parabola shifted up 4 units. So 1, 2, 3, 4. So 4 units up, that's where the vertex is. And so parabola goes up 1 over 1, up 3 over 1, up I'm afraid we're not going to be able to get this on the graph. So maybe I need to move this down some. Let me move this. Let's see here. How far would I need to move it? 1, 2, 3, 4, 5, 6. Make this a little taller. Okay. Sometimes this happens. So 1, 2, 3, 4. And now let me erase these dots here. So up 1 over 1, up 3 over 1. And then if I plug in a 3, I'm going to get 9 plus 4 is 13. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's where that point is there. Okay. So parabola, this is f of x. So f of x here. And then it also mirror image on this side, just like that. Okay. Now, g of x is a line. This one's going to be a little bit easier. I'm going to use green for g of x. So this is a line shifted down 2 units. So 1, 2 with a slope of 1. So that means rise 1, run 1, rise 1, run 1. Oh, let me try that again. Okay. And then I'm going to go this way, down that way, like that. All right. And so I'm going to put arrows here that signify that this is going forever in both directions. Now, I have x between -1, so a vertical line, x equal -1 here. So this is x equals -1 here. Vertical line is x equals a number. And then a horizontal line, if you remember, is y equal to a number. So this is x equal to 3 for this other one. So this is why I had to extend the graph out because it was such a booger. All right, so that is x equal to 3 right there. So now I want to find the area between the curves. So the area between all those curves is this area dark and gray looking color right here. So that's the area that I'm looking for, okay? So when you do this type of problem, there's 3 steps I want you to do. Step 1, draw the picture. So that means get out graph paper or, mark your tally marks. If you don't have graph paper, then you're going to need to mark tally marks on your X and Y axis so that I know, okay, that's up. This point right here is 3,13, right? So if you don't have graph paper, then you're going to have to mark it. by hand, which is no big deal. You just got to do it. Okay? So label the points that are critical. That's a critical point. Here's another critical point. Boundary corners are critical points. So 3, 1. Another critical point down here is -1, -3. I think, yeah. And then here we've got -1 and 1, 2, 3, 4, 5. Okay. So those are all my boundary points. Now, number 2, after I draw, number 2, make arbitrary rectangle. Arbitrary rectangle. So what do I mean by making an arbitrary rectangle? Come in here and draw you a rectangle where you have top minus bottom, okay? And then whatever, is it x easy or y easy? Well, I have to ask the question, is it easier for me to integrate with respect to x or to integrate with respect to y? Well, let's analyze this for just a second, okay? If I integrate with respect to x, do I use the same rectangle for the top and the bottom the whole way through? So the top starts out always being this f of x, and the bottom is g of x, f of x, and then g of x, f of x, g of x. So it looks like all the way through we have the same top, which is my f of x, and the same bottom, which is my g of x. That seems easy enough. Now analyze the dy method. The dy method, do we have the same left and right? So at this point right here, my left is this x equal -1, but my right is x equal to 3. However, what happens whenever I move down lower? When I get down to here, my left is still the same, but now the right is this line right here. And so we would end up having to break this integral up, okay, which makes it not as good to use. Here you'd have a dy for that integral. You'd have to do a dy for that integral. You need to do a dy to get that little piece, and then a dy here. So that's 1, 2, 3, 4 integrals to do dy. So that's not dy easy. Clearly, we see that our arbitrary rectangle that makes the most sense is the dx. Okay, so there's my arbitrary rectangle that I want you to draw. That's part of the problem. The last step of the problem puts everything together. Make the integral. So with your arbitrary rectangle, you figure out, is it dx or dy? Okay, that's the question you're answering, right? The reason I have you draw the picture first is because if you don't have the picture here, how in the world are you going to even know if it's easier to integrate with respect to x or with respect to y? And then how are you going to be able to set the bounds? Okay, so I'm trying to set it up for you so that when you make the integral at the end, it's easy. And if you think about dx x easy integral, what does the x easy look like? Remember, the area is equal to what? It's left to right, okay? Left to right, top minus bottom, okay? dx, that's x easy. All right? So what is this equal to? Integral from left to right. So x equals what value to x equals what value? X equal -1. That's where we start adding our rectangles. Look, just to make sure we understand what I'm talking about. We start adding rectangles here at x equal -1. Boom, 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 boom. Adding all our rectangles till we get to right here at x equal 3. So we add up infinitely many, infinitesimally small rectangles between -1 and 3. Okay? And so we go from -1 to 3. Remember, this symbol here means sum. So it's a long elongated S. We're summing up all the rectangles between -1 and +3. Okay? Top minus bottom. The top function is f of x. minus the bottom function g of x dx. Now what is f of x and what is g of x? F of x, g of x. We'll bring this down here so that we see it. So this is equal to the integral from -1 to 3 of parentheses x squared plus 4 minus parentheses x minus 2. Where I see students mess up is they don't put their parentheses around this minus part, and then they only distribute to that x and not to the -2 as well. So I emphasize putting a parentheses around both so that you don't mess it up. So this reduces to x squared plus 4 minus x plus 2 dx. I can collect like terms to make my integral a little bit easier. If I integrate this, -1 to 3, x squared, and then the 2 and the 4 combine to make plus 6. Okay. Now I'm going to find the antiderivative for x squared minus x plus 6. To find the antiderivative of x squared, I add 1 to the exponent, divide by it. Okay? To get the antiderivative here, I add 1 to the exponent, divide by it. Okay, what about 6? Really, 6 is like 6 times x to the 0, right? If I add 1 to it and then divide by it, I get that plus 6x. So the integral of 6 is 6x. That makes sense. And then I want to integrate from -1 to 3. So remember, this is fundamental theorem of calculus. Fundamental theorem of calculus says f of b, which is 3, minus f of a, which is -1. So I evaluate the integral, the antiderivative at 3. So I have 3 cubed over 3 minus 3 squared over 2 plus 6 times 3. Okay. Minus parentheses -1 cubed over 3 minus -1 squared over 2 plus 6 times -1. Close parentheses. Okay. And when you calculate this, you're going to get a lot of math, and that math is going to reduce it to 88 over 3. Okay. I guess I could simplify this a little bit. I guess that'd be 27 over 3 minus 9 over 2 plus 18. And then minus, let's see, that'd be -1/3. And then negative squared makes it positive, so that's a half. And that negative there makes it negative, and then minus 6 there. But then the negative here distributes to each of these. So all those become positives. Okay. So this is going to be 9. Okay, 9 and 18 is 27 plus 6 is what? Oh my gosh. 27 and 6 make 33, maybe? Don't judge me. All right. 9 over 2 and positive 9 over 2, that's -8 over 2, which is -4. So -4, and then plus 1/3. So that's 29 and then 1/3, right? If I multiply 3 times 29, oh my gosh. That's 787 plus 1 gets you the 88 over 3 improper fraction. Okay, good. So glad I got that arithmetic right. But I'm not so much concerned about this part here. Once you get to this part here, this is just the arithmetic, right? So maybe I give you 1 point for this part. I'd probably give you the 1 point for this part right here, getting that final answer, right? What I'm concerned about in this problem, when I'm grading it, I'm looking, did you draw the picture? Check. You labeled all the valuable points, points of interest. Did you make an arbitrary rectangle? Check, yeah. Did you set up the integral? Did I see you set up this integral? Did I see you set up this correctly? Boom, yeah, good, okay. Now, did you get the antiderivative? Boom, good, okay. And then did you get the final answer? Yeah, boom, okay. So in this part right here, there's like 1, 2, 3, 4, 5 parts to this one problem, okay? So this algebra here, really arithmetic, not even algebra, is such a small part of what I really care about whenever I'm looking at this type of problem, okay? Let's do one more that's similar but different. Okay, so this problem says find the area of the region bounded by these two curves. And so what are the two curves? The two curves are h of x equals x squared and k of x equal to 8 minus x squared. Now what's different about this? Well, in the previous example, we were given a parabola and a line, but then they told you bound it between x equals this value and x equals this value. If we hadn't have done that, then there would have been all of this extra space and there would have been an infinite amount of area that we would have found. So because we restricted it to just be between x equal -1 and 3, we were able to find that finite area there. But now this next problem has a region that's already bounded. Okay, so how do we know? Well, let's just graph it, right? Step 1, we draw the picture. So let's draw the picture first. Okay. So drawing the picture, h of x is x squared. That's easy. 0, 0 is a vertex. Up 1 over 1, up 3 over 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there. Okay. And so, oh, I thought I was going to be. Come on now, you telling me I can't? I'm going to try this one more time. I lied. Well, now that worked. That was not what I wanted, though. I don't know what's going on here. Okay. Hey, that's not too bad. There you go. That was way too hard to repeat, so I'm just not going to worry about that. Okay. All right. A little bit squigglier. Okay. So that's x squared. So this is h of x, which is x squared. And now this one is a little bit different. This one is 8 minus x squared. So since there's a minus coefficient in front of the x squared, it's actually going to be a sad parabola. See, here we had a positive, so it's a happy parabola, right? Positive, happy, negative, sad. Wah. Okay. So I'm going to go up 8 units. What was it? 8, right? So I'm going to go up 8 units. I'll do a different color. And then it's just going to be going the opposite direction, down 3 over 3, just like this. Oh, that's nice how that lined up. And if you draw your picture well, you notice that you really don't even have to figure out what the bounds are. But if you don't, you're like me, and you don't always have an iPad sitting right next to you, you may not draw your picture perfectly where it lines up beautifully. Or maybe it lines up, maybe it crosses like in this area right here, and then it's like, well, is that 0.5? I don't know. Well, how do we figure out where two graphs are equal to each other? Yep. I'm assuming you answered that. We have to set them equal to each other. Find the limits of integration okay? Got to find the limits of integration. So how do we do that? I set h of x equal to k of x. Okay, so k of x equals 8 minus x squared. Okay? So that's 8 minus x squared is equal to x squared. Now, how do I solve? I'm going to try to get x by itself, so I'm going to add x squared to both sides. So I have 2x squared equals 8, divide by 2, divide by 2, I have x squared equals 4. To get x by itself, I square root, and I get x equals plus or minus 2. Remember, when you square root, you got a possible 2 solutions, positive 2 or negative 2. So what does that mean? We cross at x equal to 2 and x equal to negative 2. All we care about are the x bounds if we're going to do x easy. And I suggest doing x easy because when I draw my rectangle, I can see here that the top is always the top and the bottom is always the bottom as I pull my rectangle through. Okay? Now, just imagine for a second if you drew it y easy. What is the left versus the right? Well, down here, the left and the right are both h of x, or the black curve. But as we get to this point right here, it switches to now it's the k of x, the k curve, the red one. So you're changing. So if you were going to do dy, you'd have two different integrals here. So that's no bueno. So we're not going to integrate with respect to y. We're going to do with respect to x. That's why we draw our picture in the first place. Okay, so shade in your region that you're enclosed, right? It's the area of the bounded region. That's this weird looking eye looking thing. Okay, so if you don't, or if you're not given the limits of integration, this is how you find them. You set the equations equal to each other. Okay, set the equations equal to each other. All right. Now, once I have them set equal to each other and I've got the limits of integration, I've got my arbitrary rectangle, I'm ready to set up the integral. The integral, okay, area is equal to what? It's from left to right, top minus bottom, dx, because it's x easy. How do we know it's x easy? From our arbitrary rectangle. And so from left to right, so the most left rectangle that I'm going to have starts with x equals negative 2, and then the most right rectangle goes to x equal to 2. Okay? So integral from negative 2 to 2. Now top, what is the top function? The top function is 8 minus x squared. 8 minus x squared minus the bottom. What is the bottom function? The bottom function is here, and that's this x squared right there. So that's x squared and then dx. And so whenever I simplify, integral from negative 2 to 2, 8 minus x squared dx gets me 8 minus 2x squared, integral from negative 2 to 2 dx. When I integrate 8, I get 8x. When I integrate negative 2x squared, I add 1 to the exponent, divide by it. Okay? And then I evaluate from negative 2 to positive 2. And so this becomes f of b minus f of a. So that's 8 times 2 minus 2, and then 2 cubed over 3 minus parentheses 8 times negative 2 minus 2 times negative 2 cubed over 3. Now, I want you to try the algebra on this, or the arithmetic on that one. See if you can get the answer. Pause the video. Okay, so maybe unpause it now. And the answer, when you simplify all of this, you get 64 over 3. Okay, so hopefully you went through that and you were able to get it yourself. Now, I want to find the area of the region bounded by these curves. So another one that's very similar to this problem. Find the area of the region bounded by these curves. Y equals x cubed and y equals 4x. Okay, so these two are the curves. First thing I want to do when I see this type of problem is I'm thinking I need to add in a graph. So I'm going to graph. Okay. All right. Okay, didn't quite make it big enough. Go figure. All right, I think this is going to work. Okay, so I want to find that area bounded by these two curves. So with this problem here, okay, y equal 4x is a slope of 4 with y-intercept 0. So that's that y equal mx plus b, which personally I think is the easiest way to plot a line. Okay, so it's a slope of 4, so that means I go up 1, 2, 3, 4 over 1. So I'll put my first dot right here. And it passes through the origin because the y-intercept is 0. 2 points is all you need to make a line. So that's what I'm going to do. And now I'm going to connect it going back this way as well. Okay. All right. Now, x cubed. X cubed kind of looks like a little squiggly like this. So, but it's centered at the origin, just like 4x. So with x cubed, actually at 1, it's 1, right? At 2, see, if you don't know what something is, you can always just plug it in, right? To graph it and plot dots and then connect your dots. It's kind of barbaric, but it does get you, it does help in a tight situation, right? 0 cubed is obviously 0. So this scenario is what this looks like here. Oh man, I'm having trouble. Okay. And then same thing going this way. We pass through here, and we pass through here. All right, so I'm looking for the bounded region. So what's bounded is this area. It's kind of hard to see, but it's that area, and it's this area. Okay? Now, the area of a region, okay, the smallest an area can be is 0. Area can only be larger, so you have to be careful, all right? And I'll come to a distinction later, but let's just start from here, okay? If we do this problem, okay, what's going on here? Well, I have 2 separate regions. Okay, I've got two separate regions. So there's region 1 here and region 2 here. Okay, maybe I'll call these regions A and B so we're not confusing numbers with something else. So I'm going to need two integrals to find the area here. Now, are they x easy or y easy? Well, when I look at A here, is it easier to do a delta x or is it easier to do a delta y? Now, the benefit to the delta y here is it's the left is always the left and the right is always the right. Okay? But then when you look at delta x, the top is always the top and the bottom is always the bottom, right? So either one of those work, but here's what I want you to think about. How is your equation given to you? In what form? Is y a function of x, or is x a function of y? Okay? So here we have y equals x cubed and y equals 4x. So when I look at this, y equals something in terms of x. This is the first scenario right here. Y is a function of x. So if I have y as a function of x, that's x easy. Okay? That's x easy. So these are already set up to be x easy. All right, now could you convert this to x as a function of y? Yes, you could. And how would you do that? You would do that by solving for x. So to do that for this one, it's not bad. Divide both sides by 4. So x equals y divided by 4. How would you do that for this one? You would do the cube root. X equals the cube root of y. Now, you could do that if you wanted to, and you'd have your, for the A region, this would be your right one, and this would be your left one. Okay, but we're not doing that. That's kind of extra work, kind of a foreshadowing for a video in which we will do, is it a function of x or a function of y, and then y easy. Because up to this point, all these videos show you how to do x easy. So I'm giving you a foreshadowing. Okay. So let's set it up, all right? For region A, integral from left to right, top minus bottom, dx. Okay, what is the leftmost one? Well, these are places where the curves are equal to each other. Well, how do we find that? We set them equal. So x cubed equals 4x. Solve, set them equal. So subtract 4x from both sides. I have x cubed minus 4x equals 0. Factor an x out, I have x squared minus 4 equals 0. This is a difference of squares. So I've got x times x minus 2, x plus 2 equal to 0. So that means I have an intersection at x equal to 0, x equal to 2, and x equal to negative 2. So this is my negative 2x value, this is my 0x value, and this is my 2x value. Okay? Those are where the graphs cross each other. The only three places that those graphs are equal to each other, believe it or not. So the first integral is going to go from negative 2 to 0, and it's the top. What is the top? That's the bendy, curvy one, which is what? That's x cubed. Minus the bottom, which is that straight black one there, which is 4x dx. Okay? That's for the first one. Now the second one, the B region. Okay, the B region. Once again, x easy. We're still dealing with the same equations. So left to right, top minus bottom, dx. Okay, what's the most left rectangle? It's 0, and then it sums all the way up to 2. So 0 to 2. And then it's the integral top to bottom. What is the top here? Uh-oh. What's happened? We switch from the curvy one being the top to the curvy one being the bottom. So now instead of 4x being the bottom, now 4x is the top. This is why we have to split it up. 4x is now the top, okay? And so if 4x is the top, that means the bottom is x cubed dx. So we have these two integrals that I need to calculate here. This one and this one. So that represents area A. This represents area B. And whenever I find those two, then I'll have the total area. Integral -2 to 0 x cubed minus 4x dx plus integral 0 to 2 4x minus x cubed dx equals, I'm going to integrate this. First one is x to the fourth over 4 minus x squared over 2 times 4. The 2 and the 4 cancel each other. And so it ends up just being 2, so it'd be x squared times 2. And then I integrate from -2 to 0. And then the second part here is x squared, 2x squared, and then minus x to the fourth over 4 from 0 to 2. And when I do a whole bunch of algebra, I end up getting 4 plus 4, which gets me 8. Okay? Now, the common mistake that I see students make here is they do this first part here, and they get this top minus bottom, and then instead of integrating from -2 to 0, they integrate from -2 all the way to 2. Now, why is that a problem? Well, the top switches from the top to the bottom for the second part, for one. Second part, right? And so what that causes is that causes this area to go from a positive area to now a negative area. And if you think about it, what do you know? You know that area above the curve is positive and area below the curve for a definite integral is negative, right? You got to be very careful in what you're saying here, okay? Because evaluating a definite integral, so say I just said from -2 to 2 of this x cubed minus 4x business, all right? That is different. This is a definite integral. Is different. It's a different problem than finding the enclosed area or the bounded area. Okay? It's different. All right? So this integral, if you calculated this integral, and I challenge you to do it, what you're going to end up getting is 0. Okay? And the reason you get 0 is because the positive area here cancels out the negative area here. Now, depending on how you set up the integral, one's going to be positive, one's going to be negative. Okay? So you must break it up into individual integrals, individual regions to solve that type of problem. So there's a difference between the definite integral and finding the area. Okay? We'll do one more just because I had requests to do more examples, so I'm going to add on to the example here. So find the integral from 0 to 2 of x squared minus 16 dx. Okay, so let's just calculate this. All right, so the integral from 0 to 2 x squared x dx, or x squared minus 16 dx. So if I calculate this, the antiderivative for x squared is x cubed over 3. The antiderivative for negative 16 is negative 16x. Evaluated from 0 to 2. F of b minus f of a. And then minus f of a here, which is 0. Now 0 is not going to affect us any here. All of this is just going to go to 0. So that goes away. And then simplify this. I have 8 over 3 minus 32, which ends up being negative 88 over 3. Okay, so that's the definite integral there. So the integral from 0 to 2 of x squared minus 16 dx equals negative 88 over 3. Okay? Now, I'm going to do a different problem, but it's going to look very similar. Find the area bounded between y equals x squared minus 16, so that's looking familiar, right? Y equal to 0, x equal to 0, and x equal to 2. Okay, so what does this look like? Well, let's drop in a sticky. So I'm going to count by 2's here. So this is down at 0, negative 16. And then this here will be my parabola. Actually, I'm going to make this scale a little bit bigger. So the scale here, let's just do a regular 1, 2, 3, 4. As long as you label your axes, then you can make it whatever scale you need to make it work, okay? So I'm not super picky. If you end up labeling stuff, then I'm really going to be lenient with you, right? Okay, so graphing this, I know it's got its vertex at 0, negative 16. Also, if I set that equal to 0 to find the y-intercept, I get x squared equals 16, which I know x equals plus or minus 4. So this is where it crosses the x-axis. Okay, so something along those lines there. All right. And then also I'm going between x equals 0, which is the vertical line here, and x equal 2. Okay. And then y equals 0, which is horizontal. If you hadn't figured this, if you didn't have me for another math class, which I guess everyone who's had Cal 1 at AC has had me for a math class, at least one, right? And so if you hadn't caught on, to find an x-intercept, you set y equal to 0, right? That's why y equals 0 is that x-axis, right? To find a y-intercept, what do? You set x equal to 0. Okay, so just that's something that whenever I finally figured that out, it really changed my life. So happy. Okay. Anyway, going back to the problem at hand, we've got this area that's bounded in here. Okay, so I'm going to use my highlighter to get this in here. Now, once you set this up, find the area of the bounded region. We drew the picture. Now we got to draw the arbitrary rectangle. Is it X easy or is it Y easy? Well, if I draw a dy, is that easy all the way through? Well, right and left stay the same. Uh-oh. Okay, let me try that again. Right and left stay the same until we get to here, and then all of a sudden the right side changes and it becomes the parabola. So you'd have to set this up as two different integrals. I don't want to do that, so I'm going to make this x easy. And so the top and the bottom, are they always the same? Yep, the top is the top all the way, and the bottom is the bottom all the way. So this is definitely an x easy problem. And so I integral from left to right, top minus bottom, dx. So what is the top here? The top is the line y equals 0. So that's 0. And then minus the bottom. What's the bottom there? Well, the bottom there is... x x squared minus 16, right? So that's the bottom curve there. Okay, so minus the bottom, x squared minus 16. Okay, dx. And so now let's calculate. What are we going from? 0 to 2. Okay, 0 to 2. So start at 0 and we sum up the rectangles to 2. So boom, 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 till we get all those rectangles. And so this is going to get me integral 0 to 2 negative x squared plus 16 dx, which equals integrate x squared, x cubed over 3 negative plus 16x, evaluated from 0 to 2. So this is equal to f of b minus f of a, which is negative times 2 cubed over 3 plus 16 times 2. And then minus, and then when I plug a 0 in for each of those, what happens? I just get 0, right? So I end up with negative 8 over 3 plus 32, which if you simplify and collect like terms, you get 88 over 3. Whoa, look at that. The area bounded between those two curves gets you a positive 88 over 3. Area is positive, thank goodness. However, the definite integral from 0 to 2 of f of x dx is negative 88 over 3. Why is this? Because when you're talking about just a definite integral, then it's area under the curve, okay, under the x-axis, right, is actually negative, okay? So since this curve is under the x-axis for this interval from 0 to 2, then that definite integral is going to produce that negative number there, okay? So that's what's going on here. So you got to be careful and know what the question is asking. Are you strictly finding some definite integral, and in which case it doesn't matter what the sign of the area is? Or are you finding that area bounded here, okay? And so those are different problems, but a concept that sometimes eludes students. So hopefully I've made a good connection for you and it helps.